Alrighty, this is solving systems of linear equations, part 3. So just a reminder, in order to solve for this system, what we need to do is we need to solve for one of the variables, x or y, in one of the equations. It does not matter which variable we choose, and it does not matter which equation we choose to solve for first. Looking at these two, we have negative 2y minus 7x is equal to negative 13, and we have x minus 2y is equal to 11. So right off the bat, I look at the second equation, I see that that one is going to be fairly simple to solve for x. So to solve for x, I just need to add 2y to both sides. So I'm going to add 2y here, and I'm going to add 2y here. And already we've solved for x, so we get x is equal to 2y plus 11. And so now we have this value, x, which is 2y plus 11. So I'm going to plug that value for x into the next equation. So we're going to have negative 2y minus 7 times x, and as we found, x is 2y plus 11, so it's going to be negative 7 times 2y plus 11, and all of that is equal to negative 13. And so now what we're going to try to do is we're going to solve for this y to get a value. So first thing I need to do is distribute. I'm going to take this negative 7 and distribute that across over here. So I have this negative 2y, which drops straight down. And then I have this negative 7 times 2y, which is going to give us a negative 14y. And then we have this negative 7 times 11, which is going to get us a negative 77. And that's all equal to negative 13. So now we're at the point where we can start to combine like terms. We have negative 2y minus 14y. And those are going to give us a negative 16y. And then we have this negative 77 is equal to negative 13. So now we're going to use SADMAP to solve for y. We have this negative 77 or minus 77. In order to undo that, we're going to add 77. Negative 77 plus 77 is 0, so these go away. And by additive identity, anything plus 0 is itself. So that's why the 16y comes down all by itself. And what we do on one side, we have to do on the other side. So I'm going to add 77 here as well. So we get negative 13 plus 77, which is going to give us 64. Now we haven't solved for y yet, so we're going to continue with our SADMAP. I see I have a negative 16 next to the y, which means it's being multiplied by the y. And in order to undo that multiplication, we're going to do the opposite of that, which is division. So we have negative 16 divided by negative 16. Anything divided by itself is 1. And by multiplicative identity, anything times 1 is itself. So that's why these negative 16s go away. And this y comes down all by itself. Or I guess it's going to come up because I'm going to put it here. And what we do on one side, we have to do on the other side. So I'm also going to divide this 64 by negative 16. It's a positive divided by a negative, so I know the answer is going to be negative. And then we have 64 divided by 16, which is 4. So it's going to be negative 4. So now we have this value of y is equal to negative 4. And if we write this as a point, x, y, we don't yet have the x value, but we do have the y value, so we can go ahead and put negative 4 in for that y value. And now that we have this value for y, we can plug that in for y in one of the equations. So I'm going to choose the equation x minus 2y is equal to 11. So we're going to have x minus, but it's 2 times y, which we found is negative 4. So it's going to be x minus 2 times negative 4. And that's equal to 11. And so what we're going to do is we're going to multiply this negative 2 times negative 4. We're going to get positive 8. So it's going to be x plus 8 is equal to 11. And in order to solve for x, we need to subtract 8 from both sides. So we have 8 minus 8, which is 0. And by additive identity, anything plus 0 is itself. So that's why these 8s go away and this x comes down all by itself. And what we do on one side, we have to do on the other side as well. So I'm going to subtract 8 here. When I was a kid, I had a sandbox. It was a sinking sandbox. And I was an only child, eventually. So we have this 11 minus 8, which is going to get us 3. And so now we get x is equal to 3, so we could plug that into the point here, 3, negative 4. And so if we were to graph the linear equation, negative 2y minus 7x is equal to negative 13, and we were to graph the linear equation, x minus 2y is equal to 11, then these two linear graphs would intersect or cross at the point of 3, negative 4. Now, in the past two videos, we've seen that you can solve for anything, x or y, in either equation. I've shown you both ways that I've solved for a variable in one, and then I've solved for a variable in the other equation, and we've always gotten the same point. But I do want to show you that you can check that you got the correct point of 3, -4 by plugging in 3 for x and -4 for y in one or both of the equations. So what I'm going to do is I'm going to use the equation -2y minus 7x is equal to -13. And what I'm going to do is I'm going to plug in 3 for x and -4 for y. So I have -2 times y, which is -4, minus 7 times x, which is 3. And if we found the correct point, all of this should equal -13. So we have -2 times -4, which is going to get us an 8. And we have -7 times 3, which is going to give us a -21. And then we bring this -13 down, and looking at this, 8 minus 21 is indeed -13. -13 does equal -13. So that does mean that, yes, we did find the right point. These values work in the equation.